18, talking about the transformations of the functions we talked about yesterday. So today we are going to start off talking about some transformed secant graphs. Reminder, transformed secant graphs are really going to just be some cosine graphs, right? If you think about these as cosine graphs to start, it's going to make our life a lot easier. Now, officially, when it comes to the amplitude of each of these, they're officially, when we talk about secant and cosecant, there are actually none officially for our amplitude because we are actually stretching vertically, or we're going like infinitely to for our y values to either positive infinity or negative infinity. Now, officially, you might also see it though defined in this case using parameter a with 2 because we are vertically stretching our graph out some. So officially, either one of these are correct answers. The 2 might be a little bit more helpful to us when we are going to graph, but you will see sometimes it represented as none. The period this time is affected by parameter b, so 2 pi over 4 is pi over 2. We have a phase shift to the left, pi over 8, and our graph is getting shifted down 1 unit. So very similar to what we do again with cosine and sine graphs, we want to start by setting up our graphs. Period, we got to repeat by pi over 2. If we divide that by 4, our little scale here, each of these are going up by pi over 8, so to the right or to the left. The next thing we want to do is sketch in that vertical shift. In this case, midline is now down at y equals -1. And again, our graph this time, we're starting out actually graphing a cosine. So our cosine shifted to the left pi over 8, and it's going to start 2 units because of that vertical stretch above our midline, so that we are actually at y equals 1, back to our midline, down the minimum amount, back to the midline, and then back up to our max. Now, instead of drawing in on these graphs the connecting the lines, remember we are actually graphing a secant, which means we're going to put in vertical asymptotes anywhere we touch that midline. And anywhere there's a max, we're going to open this graph up. Min, we're going to open the graph down. And then anywhere, again, that midline touches is a vertical asymptote. Now, for the second example of secant, again, we officially would say that there isn't an amplitude change because neither secant nor cosecant have an amplitude, but we're really going to just say, okay, our amplitude is 1 for the sake of graphing that cosine. Period, this time we would take 2 pi divided by 1/2, that's 4 pi. Phase shift this time we are going left pi units, vertical shift up 2. So our scale this time we have to repeat by 4 pi. So each of these are going up by pi to the right or the left. Our horizontal shift this time up 2 units. And this time we are going to start 1 unit above our midline. And then we had to shift to the left pi, back to that midline, down. Oops, I forgot one other thing. This reflection. Right? So that actually is going to start us at our minimum value, back to the midline, up, back to the midline, and then back down here. And again, anywhere our graph is touching the midline, we are going to want to put in a vertical asymptote. And then any of our maxes and mins are going to get parabolas. This time, because of the reflection, we're actually starting with the downward facing, and then we have the up and the down again. Now, our cosecant graphs essentially are going to just be graphs of our buddy sine. So ignore the cosecant aspect for a second. We are just going through and creating the features for our sine graph. So again, officially, 2 acceptable answers here, either none or 3 because of that vertical stretch. Again, depending on the book, it might say one versus the other. Period is 2 pi divided by 1/4, so 8 pi ends up being our period. We're moving to the right 2 pi this time, and our graph is shifted down 2 units. So 1, 2, 3, 4, we're repeating by 8 pi, which means if we divide this by 4, the scale on our graph is going up by 2 pi each time. Our midline this time is shifted down 2 units, and again, a cosecant graph is really a sine graph. So we have a sine graph starting on the midline at 2 pi, because we moved to the right. We're going up, back to the midline, down, and then extend it out a little bit, back to the midline. Anywhere we touch that midline value, we are going to sketch in a vertical asymptote. And then any maxes or mins, we are going to, again, put in a parabola up or down depending on max or min. Our final example here, test out these parameter values. Okay, we should have, again, none, or you may have said 2 for the amplitude, again, kind of depending. Period this time, 2 pi divided by 2 will give us just a period of pi. We're moving to the left, pi over 4, vertical shift, down 1. So this time, if we are repeating by the time we get to pi, each of our scale would be going up by pi over 4. And this time we'll start to the left. So we're going to sketch that in. We also are shifting this graph down 1 unit. And again, be very careful. We're starting at the midline, but our first move because of that reflection will be to move down that value of 2, that stretch, back to the midline, up, and back to your midline. All right, finally, to take this from just being a regular old sine graph to a cosecant, we're going to sketch in the vertical asymptotes and then our upward and downward facing parabolas at maxes and mins. Now, our graphs of our tangents and cotangents are just reflections off of our period functions. And again, reminder here that these have a period of pi, not 2 pi for the originals. So again, amplitude, again, you're going to see, depending on the book, officially none or 3, depending on, again, if they consider that vertical stretch part of the amplitude. Here's where we have to be very careful. Remember, it's pi, not 2 pi, divided by 1/2, so that our period is 2 pi at this time. And then write 2 pi up 2 on this. So normally, our period on our graph is 1 pi. And our tangent graphs start at pi over 2. We usually look at this, negative pi over 2 to pi over 2. Well, because we're changing this to repeat by every 2 pi, we're going to change this. We're going to kind of double this from our initial, since this is doubled from our initial. And instead of just being negative pi over 2 and pi over 2, we're going to just make this negative pi to pi. The next thing that we have to be careful of is we are shifting our graph up 2 units. So instead of starting at y equals 0, we're going to start up at 2. And then this parent function otherwise, we have to shift to the right 2 pi. So normally, again, we're going to shift here this over then. If we keep this scale going on our graph, we are going to take the graph and move it so that each one, again, is repeating by pi. So we would have 2 pi as our next piece, and then 3 pi here, since that's our scale. And if we move this piece to the right, pi units, instead of starting at 0, 0, this is now going to start at pi. And instead of our vertical asymptote being through negative pi, it's now going to be moved over that same amount Same thing with our other vertical asymptote, move to the right as well. So shifted to the right and shifted up for our tangent graph. For the next tangent graph, okay, we have this time an amplitude of either none or 1. Again, kind of will depend. The big thing here is our period this time. Pi divided by 1/4 is 4 pi. Graph moves to the right pi and up 1. So on this one, normally our parent function for our tan graphs, again, are repeating by pi over 2 and negative pi over 2. This time we are 4 times bigger, though. So we're going to multiply these by 4. And instead, these are going to repeat negative 2 pi, positive 2 pi. And if we're shifting this to up 1 and to the right 1, we're going to actually start here, 1 unit to pi. And then everything else is going to move over 1 unit, including this vertical asymptote that normally would have been here, vertical asymptote that would have normally been here. And this time what's going to happen is our reflection is going to cause this to go from always increasing to always decreasing. All right, our next one's for the cotangent graph. This one, we are moving our graph to the right pi over 2 and up 3, but otherwise our graph officially isn't really changing a whole heck of a lot. No period change this time, no amplitude stretch or anything this time. So tangent graphs normally are going to repeat by the time we get to pi, and this is kind of our parent function, right? We have this always decreasing nature. It looks something like this. Well, we are moving this so that everything is moving to the right pi over 2 and then up 3. So for our sketch, everything is going to move up 3. And if you start to the right at move everything to the right pi over 2, we're going from pi over 2 to pi then. And then that means that our vertical asymptote also is shifting over. This vertical asymptote also shifting over so that our shifted graph looks like so. For the second cotangent graph, a little bit more happening. This time, officially, we're stretching things out. We're moving to the left, pi over 4, and down 1. Now, our parent function this time and this new graph both have the same period of pi. So again, if we think about that parent function graph of our cotangent, we have a vertical asymptote through 0 and then through pi. This is pi over 2. And normally it looks like this always decreasing graph. Now, if we move this thing, though, to the left, pi over 4, that's basically one box that everything's moving to the left. And then we're also moving down 1 so that it's left and down from what it originally was. Now, this time we also want to be careful of the reflection. So instead of always decreasing, our graph is actually going to look like it is always increasing this time, going upwards. All right, I know we will work more with these in class. Thanks everyone for watching.